We are discussing atmosphere, and composition of atmosphere was going on, and we have discussed some gases. Composition of atmosphere, and we have discussed the gases like nitrogen, oxygen, argon, carbon dioxide. These are the gases we have discussed, their significance we have discussed. Let's move on and take up some more gases. Like next gas is water vapor. Water vapor. Fine. In our atmosphere, water vapor plays very important role, and by 1 to 4% by volume, we have water vapor. 1 to 4% by volume, we have water vapor. What are the role of this water vapor? If I say that this water vapor is the engine of our atmosphere, it is the engine that is responsible for hydrological cycle. It is the engine which is responsible for cloud formation, rainfall, fog, dew, mist, and all weather phenomena which you find in our atmosphere. This water vapor is basically transparent to insolation, incoming solar radiation, and hence the incoming solar radiation fall onto the ground. But this water is not transparent to outgoing solar radiation, long wave solar radiation, terrestrial radiation. Water vapor absorb long wave terrestrial radiation, and it cause same the greenhouse effect. Greenhouse effect. As I told you yesterday that carbon dioxide as well as water vapor both are responsible for this greenhouse effect. If this greenhouse effect would not be there, the earth would not be habitable place, isn't it? So this greenhouse effect, partly it is done by carbon dioxide and water vapor. Water vapor. Apart from it, water vapor is responsible for rise of convectional current, rise of convectional current. What is it? I'm just going to tell you. Condensation, cloud formation, rainfall are different form of precipitation, whether it is rainfall, hailstorm, snowfall, or something like that. Apart from it, dew, fog, mist, these all phenomena associated with water vapor. Okay, so you can take down water vapor. Water vapor constitute 1 to 4%, 1 to 4% by volume, 1 to 4% by volume. It is transparent to incoming solar radiation. It is transparent to incoming solar radiation, but absorbs long wave terrestrial radiation. But absorbs long wave terrestrial radiation. Yesterday, you asked that why sir absorption is so specific. It is because of the specific absorption maxima of each and every chemical. absorption maxima. So long wave terrestrial radiation has the energy which can be absorbed by the water vapor. That's why it is being absorbed and causing greenhouse effect. Absorption of terrestrial radiation and causing greenhouse effect. Greenhouse effect. Further, next point, 90% of water vapor, 90% of water vapor confined within 5 kilometer of atmosphere. So the lower atmosphere, the 5 kilometer consists of almost 90% of water vapor. Isn't it? Next line you can write. Amount of water vapor decreases on moving from equator to pole. On moving from equator to pole. Near pole, near equator, we find maximum water vapor in air. We find maximum water vapor in air, while at pole it reduced to 1% only. It reduced to 1% only. So why this amount is going to be low? What is the reason behind it? Evaporation. Very good. So evaporation, it is at equator at 27 degrees centigrade. So rate of evaporation will be high. So higher rate of evaporation will give more water vapor into the air. And what about pole? You have low temperature. And at low temperature, what do you think? Suppose that the temperature is 0 degrees centigrade. Will it be evaporation there? Answer is yes. Evaporation can occur at all temperature. Indeed, the rate of evaporation is low. Rate of evaporation is low. There is a little bit exception of this trend. You will find less water vapor even at the tropics, especially at the western margin of the continents. So you can take down note that amount of water vapor is less, almost 1% or even less than that, near the tropics at the western margin of the continent. Near the western margin of the continent, you will get less water vapor over there. Why? Despite of high temperature, even in summer the temperature goes means more than 27 degrees centigrade. Even then you are going to have low water vapor. It is attributed to non-availability of water body. So if water body will not be there, so from where you will go for evaporation? So less water body. That's why at the western margin of the continents, we happen to have low water vapor. And apart from it, the zone is having subtropical high pressure belt. Subtropical high pressure belt create anticyclonic condition over there. And this is the reason why the deserts are being formed at western margin of the continent in the tropics. This will be clear when we discuss the pressure belt and all. But for now, you understand there is low water vapor because of non-availability of water body. Apart from it, there is subsidence of air. They are subsiding over there, creating anticyclonic condition, and that prevent any possibility of rainfall. This is the reason there is less water vapor and desertification takes place. You'll find all the hot desert of the world, they are at western margin of the continent. These are few reasons. I will tell you further more reason while we complete the class of climatology and the basics of what? Pressure belt and planetary belts. Then you get to know everything. For now, you just have the idea that yes, at the tropics, despite of high temperature, we happen to have low water vapor content because of non-availability of water body as well as subsidence of air. Isn't it? Fine. So what are the work assigned to water vapor? One is what? Greenhouse effect. What is second work? There is evaporation. This is the water body. And when there is evaporation, this is water vapor. Tell me, water vapor is lighter than air or heavier than air? Lighter than air. So you will always see that when water is boiling, vapor is going up. You can take the molecular weight of water as well as air. So water vapor is lighter. So what happened? After evaporation, water vapor rise up and then it form cloud, and the process is called as condensation. And after condensation there will be rainfall. After condensation there will be rainfall, maybe other forms of precipitation, maybe snowfall, maybe hailstorm. We'll learn it in the process. But yes, after condensation there will be rainfall. Suppose that this water body is ocean and there is a continent also. And you want to spread the life form on the continent, because you all have the idea that life was originated in the ocean and then from ocean it turned towards the continent. And on continent, if you want to establish life, you require water. So you require one motor, one pumping set that can pump the water, fresh water to the continent. So who is going to do this? Water vapor itself is going to perform this work. So here evaporation takes place, condensation takes place, and there is formation of cloud. This cloud give rainfall to this terrestrial area. There will be surface runoff. Then further this water come into the water body through so many rivers, and then you happen to have water content on the continents, and then the life form start moving towards the terrestrial ecosystem from the marine ecosystem. And this is how the earth get diversified biodiversity, isn't it? So who is going to be pivotal here? This water vapor. Why water can do all these work is because of the one fact that water has a latent heat. It absorbs 540 calorie per gram heat, that is latent heat of vaporization, then it turns into vapor, isn't it? And then when condensation takes place, it shed all that heat and it turns into water droplet, then fall onto the ground. So the heat which is taken by the water, carried by the water, is basically the heat engine responsible for all these weather phenomena. All these weather phenomena means rainfall, condensation, cyclone, tropical cyclone, temperate cyclone, dew formation, frost, everything is because of this water vapor. And the water vapor has a characteristic feature that it has a power to carry heat, and that is what? Latent heat, isn't it? So this latent heat is responsible for rise of convectional current also. So in equatorial region, you will find that heating is responsible for rise of air, and along with air, this water also. And due to movement of water vapor upward, water vapor get cooled and condensed, and this heat released over there. Let me explain this. Like, suppose that there is a water body over here, and due to high temperature, what happened? There will be low pressure, air will start moving up. Fine. And simultaneously, because of evaporation, water vapor is also start moving up. This is what? Air, here it is water vapor. Air plus water vapor. Fine. Now what? This air will move up along with water vapor and get cooled. Isn't it? Because this water vapor has a latent heat. How much? 540 calorie per gram. This is the heat absorbed by the 1 gram of water, and then there is a change of phase, isn't it? यही एक्स्ट्रा हीट होती है स्टीम में, तभी तो आप स्टीम से ज्यादा जलते हो, ऐसा पढ़ा है ना आपने? So this extra heat carried by the water vapor, then this vapor goes up, and as we move up, there is temperature that goes down, and there will be temperature at which you will find formation of cloud. And once the formation of cloud is taking place, what happened? The latent heat of vaporization released in form of heat of condensation. Same amount of heat released here. Fine. And this heat, which is released just after the formation of cloud, further heat the air which is present over here, isn't it? And there is continuous supply of water vapor going on. Further, this heat released start lifting the air up. Again, there will be condensation because this water supply is there. Again, there will be rise. Again, there will be condensation. And this process goes on. This process goes on every time there is release of heat. And this heat is what? Heat carried by the water vapor in form of latent heat. And every time it rises up. Such rise, such massive rise is called as rise of convectional current, isn't it? And this convectional current, especially in equatorial region, 0 to 5 degree north, 0 to 5 degrees south, you will find this kind of rise of convectional current taking place. And from morning to 4 p.m., there will be this process going on. And you will find vertical extent of cloud formation up to 4 p.m. and after 4 p.m. there will be rainfall. This is everyday phenomenon. It is because of rise of convectional current. And who is responsible for this rise? The latent heat. And the latent heat is intrinsic property of the water vapor. And this is why and how the water vapor is responsible for all weather phenomena. Isn't it? And this is also responsible for releasing this heat to the space. If you remember that class when we discussed the evolution of atmosphere, the cooling of the earth, there was 500 million year continuous rainfall. Isn't it? And this rainfall lead to faster cooling of the earth crust. And how this rainfall was taking place? There was a rainfall, immediately evaporation, and once evaporation is taking place, it takes the heat of the earth in form of latent heat, release it to space, then again rainfall. So this latent heat was responsible. So in this way, we can understand that this hydrological cycle is completed only because of the virtue of water vapor that it has latent heat, isn't it? Although this is not the complete hydrological cycle, because this ocean will immediately have some kind of grievances with the terrestrial system, that every time the continent is getting some water percolated down and it become the part of groundwater. Every time it was happening. So water body requested to nature, I cannot sustain this business because every time whatever the evaporation is going on, some part of the water gets stashed from me and it become the part of groundwater. So how come I can continue this loss making business? Then nature did one thing marvelous, and that is what? Created vegetation. So when the vegetation created over here, what happened? These vegetation are responsible for taking all these water from the ground because it has long roots. So taking all these water and maintain the soil, air, water continuum, isn't it? So whatever the water is stashed in form of groundwater is also in the cyclic process, and then hydrological cycle get established here. This is the reason why if you denude the area, if you clear the area from vegetation, the hydrological cycle get disturbed and you are not going to get rainfall and the area turned into deserts. This is the reason why vegetation or forests are termed as friend of the farmers. They are helpful in rainfall. Why? Because it maintains soil, air, water continuum. Soil, air, water continuum maintained by these vegetation. You understand how? Because the vegetation perform one very peculiar phenomena that is called as transpiration. You heard about that? Transpiration. In order to evade the high heat shock, the plants used to evaporate the water from their, leaves, shoot part. There are stomata through which water comes out. When water comes out, there will be evaporation, and evaporation will take all the heat from the plant in form of latent heat, and there will be cooling effect. That's why the vegetation perform what? Evaporation, transpiration. And now there is evaporation और इसका एक दोस्त मिल गया plus transpiration. So what happened? Evapotranspiration. आपने environment में पढ़ा होगा water cycle. So now the earth has not only evaporation, rather evapotranspiration, and this evapotranspiration is responsible for taking this water which was earlier stashed in form of groundwater in a continuity, and the business of hydrological cycle get established. Indeed, you understand? So there will be evaporation plus transpiration, condensation, rainfall, some part get percolated as form of groundwater, some comes in form of surface water, and because the groundwater is not going to be stashed entirely, it is in the process of cycle. That's why this business goes on, this hydrological cycle goes on. If you clear the vegetation, you are going to break this continuum, and in that case, you happen to have scarcity of rainfall. And this is the reason why forests are intrinsic to rainfall, or in other words, water cycle. Is it understood? So the entire water cycle, cloud formation, rainfall, fog, frost, dew, whatever you listen about the water vapor is attributed to the latent heat, which is the virtue of the water vapor. Is it okay to everyone? Fine. So you want to write what you have written? Okay, fine. Next you can take down. Water after absorbing 540 calorie per gram heat energy, 540 calorie per gram heat energy turned into water vapor. Further, on cooling, this much heat released, in form of heat of condensation. Heat of condensation. There is formation of cloud followed by precipitation. Formation of cloud followed by precipitation. Precipitation takes place in different forms, like rainfall, snowfall, sleet. What is sleet? Mix of rain and snow. Sleet or hailstorm. Hailstorm. Apart from it, water vapor is responsible for dew, frost, fog, mist, etc. Dew, frost, fog, mist, etc. And not only this, water vapor, basically the latent heat. Water vapor is also responsible for genesis of cyclone, local turbulence, cloud burst phenomenon. So, who is behind it? Water vapor, especially this latent heat. Water vapor has also been given the responsibility of heat transfer. Fine. It has been given the responsibility of heat transfer. Isn't it? So these are the work performed by the water vapor. Along with carbon dioxide, it is going to perform the greenhouse effect. In the last class, we have discussed what it is. It is the absorption of long-wave terrestrial radiation and then counter radiation released by this system, and there is heating effect. Is it okay to everyone? Fine. Next important gas is ozone. आएगा ozone. We have two types of ozone. One in stratospheric ozone. Another tropospheric ozone. Fine. One is good ozone and another one is bad ozone. So which one you want to understand first? Tropospheric ozone. That is what? Bad ozone. So this is bad ozone. And here it is good ozone. So if you understand what is the goodness of this ozone, then it would be easy to understand why tropospheric ozone is bad ozone. Fine. So this ozone is triatomic form of oxygen. 3 oxygen atom joined to form ozone. So I'm just going to discuss stratospheric ozone, then I will come on to the tropospheric ozone. It is a bad ozone. Now it is a pollutant. Pollutant. More precisely, it is secondary pollutant. Secondary pollutant. Fine. So let's come to the stratospheric ozone. Stratospheric ozone. Fine. So you all have this idea. This is the Earth's surface. Just above the Earth's surface, there is a zone of troposphere. I will discuss in detail. Then you will find stratosphere. Stratosphere. So up to, on an average, 13 kilometers from the Earth's surface, you happen to have troposphere, and above which, up to 50 kilometers of height, you have this stratosphere. I will go for the detailed study of this stratosphere. And in this stratosphere, you will find this stratospheric ozone. Fine. What is ozone? Ozone is triatomic form of oxygen. Triatomic form of oxygen. Fine. Triatomic form of oxygen. It is colorless, odorless, transparent gas, confined to stratosphere. Okay. Confined to stratosphere. How it is going to be formed? What is the natural process of ozone formation? Natural ozone formation. You all have this idea, this ozone is a protecting cover upon this Earth's surface. If ozone would not be there, we all become roasted chicken, because ultraviolet B rays will reach over here and life would not be possible. Means this much diversity will not be possible. Are you getting my point? Fine. So how this natural formation of ozone taking place in stratosphere? So what happened due to lightning event? Oxygen split into nascent oxygen. These are the nascent oxygen free radical, and has a singlet electron, and they are very, very reactive. And once, this is because of lightning, wherever it get heat, because of lightning, oxygen is split into nascent oxygen. Further, this system release this heat, and this nascent oxygen reacting with oxygen and forms ozone. This is a natural process of ozone formation which is going on in stratosphere. Continues to be there, but the rate of natural formation is very slow. So rate of natural formation is very slow. Natural formation of ozone is slow. And this is how ozone gas is continuously getting formed in stratosphere. You have the understanding now? Fine. This is the reason why stratosphere has been called as ozonosphere. You happen to have ozone, presence of ozone gas in stratosphere. Presence of ozone gas in stratosphere. This is what? The stratosphere up to 50 kilometer of height. If you take equator, so there is 18 kilometer. If we talk about pole, so there is 8 kilometer up to 8 kilometer troposphere. This is what? 50 kilometer. Fine. In a stratosphere, you happen to have ozone. How it is formed? Because of because of heating effect, because of lightening, oxygen broken into nascent oxygen, one nascent oxygen react with molecular oxygen and forms ozone. Is it okay? This zone is called as ozonosphere. There is lot of ozone concentration over here. Is it okay? And this ozonosphere is performing some work for us. You all have the spectrum of insolation we discussed in the class. And in that class, I talked about ultraviolet rays, isn't it? Ultraviolet B. And I said to you, please remember it. It will again come to you when we discuss atmosphere. Ultraviolet B rays, they are high energy radiation of the range 280 nanometer to 320 nanometer. This is the ultraviolet rays which is basically absorbed by the ozone. And this ultraviolet rays, if reach onto the earth's surface, it can be lethal to many life forms, including human being. It is going to have deleterious impact. It can cause skin cancer, it can cause damage to cornea, it can create dimerization of your DNA and mutation, isn't it? There are many microbes which is going to die simply because of exposure to ultraviolet rays. And if microbes get dead, so don't you think the process of decomposition get altered? Isn't it? And if the process of decomposition get altered, so what happened to the soil mineral pool? We discussed this now. The soil mineral pool is not going to be recharged. If the soil mineral pool is not going to be recharged naturally, so what happened to the productivity? What happened to the agricultural productivity? Get reduced. So we will all face problem of food security. That's why this ultraviolet B rays has to be stopped. And ozone is playing very pivotal role by absorbing this ultraviolet B radiation. It is absorbed by ozone and doesn't allow ultraviolet B radiation to reach onto the earth's surface. Is it okay to everyone? So is it doing good job or bad job? Good job. That's why it is called as good ozone. Isn't it? Fine. So what is the cycle which is going on over here? First cycle, that there is formation of ozone, in which you will find formation of nascent oxygen because of lightening effect. Then this nascent oxygen react with oxygen and form ozone. This is what natural cycle of ozone formation you have seen. Now what happened? This insolation coming over here, containing all its high energy radiation. Out of this insolation, ultraviolet B get absorbed in ozonosphere, and then you have insolation reaching onto the earth devoid of UV radiation, UVB radiation, isn't it? So this is the insolation containing visible light as well as long wave radiation, that is what far red, far infrared, radio waves and all that, which is not going to cause any kind of deleterious impact on the life form of the earth. So this insolation is allowed, but yes, here ultraviolet B rays get trapped. UVB, it get trapped. How it get trapped? Because there is a ozone cycle which is going on in the ozonosphere. What kind of ozone cycle? Let me explain this. This is the ozone which is formed, and when ultraviolet rays fall over here, this ozone absorb this ultraviolet rays and split into oxygen and nascent oxygen. Fine. Oxygen and nascent oxygen. So in the daytime, when there is ultraviolet rays, it will absorb this ultraviolet rays by splitting the bond. Oxygen and nascent oxygen get separated. isn't it? And when the night prevailed, isn't it? So what happened? At that time, this system, this oxygen and nascent oxygen, this is gas now, will release the heat that was basically absorbed here. And this heat further cause what? Joining of oxygen and nascent oxygen. Fine. Oxygen and nascent oxygen further join with each other and they constitute ozone. Ozone फिर से बन गई बच्चे. And this is what called as ozone cycle. Ozone cycle. So what is going on? The ozone is absorbing ultraviolet B radiation split into oxygen and nascent oxygen. And this system release the heat, and under the impact of this heat, oxygen and nascent oxygen recombine to create ozone. So every time the ozone was splitting, absorbing the energy, releasing it, further reformation of ozone taking place. And this cycle was going on in a stratosphere. But what happened? क्या हुआ कि हम लोग इमोशनल आदमी, कुछ कविताएं बोल दी गई, पढ़ ली गई. कौन कहता है कि आसमान में सुराख नहीं होता, कुछ पत्थर तो तबीयत से उछालो यारो. तो हम लोग पत्थर उछालने लगे. क्लोरोफ्लोरोकार्बन है ना, कार्बन टेट्राक्लोराइड, जिससे क्लोरीन फ्री रेडिकल निकले, ब्रोमीन फ्री रेडिकल निकले, नाइट्रोजन के ऑक्साइड्स, दीज ऑल आर ओजोन डिप्लीटिंग सब्सटेंस. हमने ही उछाले हैं ये पत्थर और सुराख हो गया आसमान में. सुराख हुआ तो अल्ट्रावायलेट रेज हालचाल पूछने आने लगी. उनका आना ठीक तो था नहीं, बिकॉज दे आर लीथल. सो ओजोन डिप्लीशन वाज देयर. हाउ? बिकॉज दिस nascent oxygen is very reactive, and we have just thrown some, means obviously we released ozone depleting substance. These ozone depleting substance are potential kidnapper of this nascent oxygen. नवजात कहते हैं इसे, छोटा बच्चा है, चंचल. These are the free radicals, and these free radical trap this oxygen, and now this oxygen get trapped, this nascent oxygen get trapped by these free radical. So tell me, if this nascent oxygen get trapped by these free radical, the cycle will be blocked or not? Yes. So what happened? The complete cycle, this part is not going to take place at same place, because same pace, because this nascent oxygen was taken by the ozone depleting substance free radical. It may be nitrogen oxide, it may be carbon tetrachloride, it may be chlorofluorocarbon, hydrobromocarbon. So many ozone free radical, means ozone depleting substance are there, which will be taken care in your environment and ecology, isn't it? So this oxygen trapped, and they just hide somewhere. I will tell you the hiding place also. Fine. And then what happened? The process of reformation of ozone was blocked. And you all have this idea that this process, the natural formation of ozone was slow. That's why the net ozone amount in stratosphere start declining. And due to that, ozone depletion have taken place, isn't it? Ozone depletion have taken place. And after ozone depletion, ultraviolet B rays can now reach onto the Earth's surface. I'm just telling you the story. Fine. So please take down. Ozone can be of two types. The good ozone as well as the bad ozone. good ozone as well as the bad ozone. Stratospheric ozone is good ozone. Stratospheric ozone is the good ozone. As it is responsible for absorption of ultraviolet B radiation, as it is responsible for absorption of ultraviolet B radiation, which is lethal and very harmful, which is lethal and very harmful to the biodiversity, on the earth surface, including human being. So what kind of lethal effect? It has already been covered, I think so. Lethal effect of ultraviolet B radiation. It is going on. So I'm not going to touch that. You have the idea, pretty idea, but you listen one thing, that it is going to cause skin cancer. It can be harmful for the eyes and cornea, damage to cornea. In human being, it can damage the DNA, our genetic material, and create mutation. You know what is the mutation? There is a change in the genetic material and you happen to have a different kind of maybe defect in the species, isn't it? So that is what mutation. Again, this ultraviolet rays is what? Lethal to microbes. It is going to increase the body temperature of the microbes and microbes will die. And if the microbes die from the soil, your soil microflora get damaged. So the soil mineral pool, process of soil mineral pool gets ceased. Your soil is now having complex organic material, but not availability of mineral is going to be stopped. So it will certainly reduce the productivity. That's why we can see the impact of ultraviolet rays on human, on ecosystem, even on agriculture and hence economy, isn't it? So these all are the dimension which is going to be affected by the ozone depletion. And that's why we have some protocol to combat ozone depletion. Vienna, Montreal, and then there is Kigali amendments. So up to Kigali amendments you must be prepared, isn't it? Fine. So it absorbs ultraviolet B radiation, hence it is called as good ozone. Further you can write, ये लिख लिया है? Ozone is a triatomic form of oxygen. जैसे कार्बन के कई सारे फॉर्म्स होते हैं ना, कोल, ग्रेफाइट, डायमंड. Similarly, this oxygen is also having different form. So triatomic form of oxygen is called as ozone, which is colorless, odorless, transparent gas. Colorless, odorless, transparent gas. Natural formation of ozone is taking place natural formation of ozone is taking place in a stratosphere, and it is due to the heat generated during lightening. During lightening, the natural formation of ozone is slow. The natural rate of formation of ozone is slow. Let's come to the process, this ozone cycle. Ozone absorbs ultraviolet radiation. Ozone absorbs ultraviolet radiation, split into molecular oxygen, and nascent oxygen. Molecular oxygen and nascent oxygen. Nascent oxygen is very reactive. Nascent oxygen is very reactive. When the heat released, they further recombine. They means oxygen and nascent oxygen. They further recombine to form ozone. They further recombine to form ozone. The cycle is going on. This cycle is going on, which we call ozone cycle. We human being released some ozone depleting substance like chlorofluorocarbon, chlorofluorocarbon, chlorobromo, carbon tetrachloride, oxides of nitrogen are NOx, लिख लीजिए NOx. We release this ozone depleting substance, producing nitrogen and chlorine free radical. NOx producing nitrogen and chlorine free radical. These free radical react with nascent oxygen. These free radical reacts with nascent oxygen, sees the completion of ozone cycle. Sees the completion of ozone cycle. So what happened? Slowly and gradually, concentration of ozone, the concentration of ozone start retarding slowly and gradually. Try to see it here. If the cycle is not going to be completed, there will be destruction of ozone that is going on and reformation of ozone gets ceased. Why? Because the raw material was this and it was taken by the free radical. So completion of cycle will be stopped. So slowly and gradually there will be only destruction taking place, but no reformation taking place. So what happened? the concentration gradually get retarded. That leads to ozone hole. That leads to ozone hole. Concentration of ozone get retarded, get reduced, get lowered. जो अच्छा लगे वो आपका. तो क्या होगा बच्चे? Slowly and gradually concentration of ozone get reduced, retarded. That leads to ozone hole. तो बात आगे पहुंच गई है कहां तक? ओजोन होल तक. ठीक है बच्चे, ओजोन होल. चलो जरा देखते हैं, एक सवाल छोटा सा पूछूं, बताओगे? कंसीडर द फॉलोइंग स्टेटमेंट. यूपीएससी टाइप से पूछते हैं. कंसीडर द फॉलोइंग स्टेटमेंट. A ozone hole is an area in stratosphere where there is no ozone. B ozone depletion largely takes place. Ozone depletion confined to polar region. C concentration of ozone measured in Dobson unit. Which of the following statement is are correct? First, all. Second, A and B. Third, B and C. And the fourth, A only. बताइए. Consider the following statement. These are the three statements. First statement state that ozone is an ozone hole, not ozone. Ozone hole is an area in a stratosphere where there is no ozone present. Fine. B ozone depletion confined to polar region. कहाँ only? नहीं, only नहीं है. Concentration of ozone measured in Dobson unit. What is your take? Huh? Yes, concentration of ozone is measured in Dobson unit. That is true. तीसरा, B and C are correct. This B and C. What about ozone hole? थोड़ा सा होगा. So यही मैं बताना चाह रहा था कि even in ozone hole there is some amount of ozone left. So how much this is? We have to find it out. पता करते हैं. अच्छा, एक प्रॉब्लम और भी है. Yes, you are right that B and C is correct. An ozone hole is not completely devoid of ozone. There is some amount of ozone present. There is concentration of ozone which is present over there. I'm giving you some more clue about the newspaper also with this regard, in this regard. Fine. B and C, these are correct. mostly this is going to happen in the polar area. If it was only, then it is going to be wrong. Okay, so let me explain this. I am actually want to have this idea that in ozone hole there is considerable amount of ozone present. One thing more, you all have this idea that ozone in the stratosphere is in form of layer. Is it in form of layer? You might have seen this name, ozone layer. सुनते हो ना ozone layer? So what is ozone layer? Is it like layer or it is just the concentration of ozone? Is it layer? So means it is not like layer. It is homogeneous combination of gases, just like the nitrogen and oxygen here. It is not like कि नीचे हो जाए तो ज़्यादा ऑक्सीजन आ जाए, ऊपर हो जाए तो नाइट्रोजन. It's not like layer. Can you find layer of nitrogen and oxygen here? No. Similar homogeneous combination you will find over there. There is no layer. Even then you call it layer. And in some book you will find that the thickness of this layer is also given. And how much? 3 millimeter. Isn't it? Ozone layer, average thickness 3 millimeter. How many of you have seen this statement? And this is right. But it is just the composition of ozone. Why this composition has been named as a layer? There will be something, and all those answer is hiding behind it. There was a person, Gordon Dobson. Dobson यूनिट देखा है ना? यही साइंटिस्ट थे, गॉर्डन डॉब्सन. And he measured ozone concentration in stratosphere by using spectrometry. And the instrument was named Dobson spectrometry. ठीक है? Dobson spectrometry, and simply further it was named Dobson. Fine. And he gave the unit Dobson unit. So whenever you measure the concentration of ozone, it has been given in Dobson unit. So this, he measured by using this technique the average concentration of ozone in a stratosphere, concentration of ozone, and it happened to be 300 Dobson unit. 300 Dobson unit. तो उन्होंने क्या दिया? 300 Dobson unit. तो आप पूछोगे ना, चाचा ये बताओ Dobson unit का मतलब कैसे मान लोगे? क्या ख्याल है? पूछोगे कि नहीं पता चल गया? तो चाचा ने बताया कि देखो बेटे, Dobson यूनिट का मतलब क्या है कि 1 Dobson यूनिट ozone is that amount of ozone. ध्यान से सुनना, 1 Dobson unit ozone is that amount of ozone which is required for creating a layer of 0.01 millimeter. That means the amount of ozone will be considered as 1 Dobson ozone when it is going to create a layer of 0.01 millimeter in a stratosphere. And the average concentration of ozone in a stratosphere was 300 Dobson unit. 300 Dobson unit. So how much? 3 millimeter. So this 3 millimeter average thickness of ozone layer is a hypothetical what? Layer phenomena. It's not like layer. When you hypothetically compress all ozone of stratosphere at one place, then it is going to constitute 3 millimeter thick layer. Who tell this? Gordon Dobson. Fine. So if this thickness is of 3 millimeter or 300 Dobson unit, उनको भी पता था कि यार Dobson नाम रख देते हैं, मुझे कौन याद करेगा. अपने नाम पे रख दिया। इन्होंने कहा कि इफ दिस थिकनेस, द एवरेज थिकनेस ऑफ ओजोन लेयर is how much? 300 Dobson unit, 300 Dobson unit, then this is pretty normal. This is the normal thickness of ozone, and it does not allow ultraviolet rays, ultraviolet B rays to pass. But yes, if this concentration reduced below 100 Dobson unit. What I said, if this concentration reduced below 100 Dobson unit, then this area is going to be called as ozone hole. Ozone. Why? Because the 100 Dobson unit ozone is not able, below 100 Dobson unit ozone is not able to trap ultraviolet B rays. Now this ultraviolet B rays can cross the ozone layer. How much concentration? Less than 100 Dobson unit. This is what ozone hole, or we call it ozone depletion. Ultraviolet B rays can pass through it. Is it okay? So you understand the concept of ozone layer, Dobson unit, as well as ozone hole. So in case of ozone hole, this is what ozone hole, you happen to have less than 100 Dobson unit ozone left. Isn't it? अच्छा, कितने लोगों को लॉकडाउन का टाइम याद है? उस समय एक न्यूज आई थी, क्या ओजोन लेयर भर गई, और यहाँ के न्यूज़पेपर कुछ जो बुद्धिमान पत्रकारों द्वारा चलाए जाते हैं, उन्होंने लिख दिया था बड़ी बड़ी बातें। क्या लिखा था? कि दिस इज बिकॉज ऑफ लॉकडाउन, रिडक्शन इन पोल्यूशन एंड ऑल। ओजोन लेयर तो भर गई थी, बट जो उन्होंने रीजन दिए थे वो उनके अपने थे। तो समटाइम दीज न्यूज़पेपर वाला आल्सो डेवलप देयर ओन साइंस एंड कॉन्सेप्ट। गुड न्यूज़पेपर वाला, they never go for any apology also. They have given the explanation that it is attributed to the lockdown. Because of lockdown, less emission, and due to less emission, less pollution, ozone layer replenished. तो हुआ कि चाचा तुम थोड़ा ठीक से एक्सप्लेन करो। देयर इज कोपरनिकस फाउंडेशन इन यूनाइटेड स्टेट्स ऑफ अमेरिका, उसने बताया कि ozone layer replenished on Antarctica as well as Arctic region, both because of unprecedented polar vortex, not because of lockdown. इन्होंने तो यहां तक लिख दिया था कि ऐसे लॉकडाउन तो हर बार होने चाहिए, उत्सव की तरह मनाए जाने चाहिए। बहुत बड़े बड़े मूर्ख पड़े हुए हैं। जरूरी नहीं कि न्यूज़पेपर में लिखी सारी बातें अथेंटिक हो, एक्सेप्ट सम अथेंटिक न्यूज़पेपर विच यू फॉलो। आई नो, मैं ऑफिशियली नहीं बोलता, लेकिन हाँ कुछ न्यूज़पेपर अच्छे हैं, लेकिन कुछ न्यूज़पेपर में कैसे लोग काम कर रहे हैं थोड़ा संशय का विषय है। तो बी केयरफुल अबाउट दैट। अनप्रेसिडेंटेड पोलर वर्टेक्स, और वो अगर अभी समझाऊंगा तो नहीं समझोगे। लेट द टॉपिक ऑफ व्हाट एटमॉस्फेरिक सर्कुलेशन कम, सम मोर अंडरस्टैंडिंग ऑफ एटमॉस्फेयर, देन आई विल लेट यू नो कि व्हाई पत्थर कहां उछले, ट्रॉपिक्स और टेम्परेट रीजन में यहीं उछले थे ना पत्थर। होल कहां हुआ? पोलर रीजन। कैसी विडंबना है, बताइए सर कवि जी। इज इट राइट? मोस्ट ऑफ द ओजोन depleting substance released in the temperate as well as tropical region, these are the developed countries as well as developing country, but you happen to find ozone depletion in the polar area. And there are many explanations, and I know that it is not going to be complete until unless you understand some concept. Then the collective phenomena is going to lead such kind of concentration of ozone depleting substance over there, and you require some time to understand it. आप पढ़ लीजिएगा अभी, फिर मैं एक्सप्लेन करूंगा क्लास में. There will be cause and the effect. You will see both, but it is involving polar vortex, height of tropopause, polar stratospheric cloud, which I am going to discuss, as well as tricellular atmospheric circulation. So when you have the understanding of all these four phenomena, then you can understand how these ozone depleting substance released in the tropics, in equatorial region, in temperate region, accumulated in the polar region. तो अभी तो नहीं बताऊंगा, और polar vortex भी उसी समय बताऊं. But yes, it is not because of lockdown at all, it is because of unprecedented polar vortex. The polar vortex remains stronger. Polar vortex usually become weaker in the summer season and stronger in the winter season. But what happened in nature, it is still the matter of research. That year, the polar vortex was so strong, it was not weakened even in summer season. That's why ozone replenished. Ozone get a chance to replenish. Try to understand in this way. I will ensure that you will know everything. But give me time so that I can take you all up to that level. Fine? तो यहां तक समझ गए ना? लिख लीजिए. Ozone present in form of homogeneous concentration in a stratosphere, homogeneous concentration in stratosphere, fine, homogeneous concentration stratosphere. Gordon-Dobson measured ozone concentration and stated that TOMS is 300 Dobson unit. TOMS, total ozone maps. Okay, and stated that TOMS, total ozone maps, total ozone concentration, total ozone maps is 300 Dobson unit on an average. 300 Dobson unit on an average. ठीक है? So total ozone mapping, that means ozone concentration mapping. Simple. The name has been given TOMS. Now, TOMS is 300 Dobson unit. 1 Dobson unit of ozone, 1 Dobson unit of ozone is that amount of ozone required for making 0.01 millimeter thick ozone layer. 0.01 millimeter thick ozone layer, and hence the total thickness कितना होगा? 3 millimeter. Hence the total thickness, and this is average total thickness of 3 millimeter. From here, the concept of ozone layer evolved. So why we call it ozone layer? This is the explanation. Another explanation is that it acts as protecting cover. That's why ozone layer, isn't it? But once they ask 3 millimeter, so this is what? Hypothetical condition. When we compress all the ozone of the stratosphere, it is going to constitute 3 millimeter thick layer. That correspond to 300 Dobson unit. And one Dobson unit, you know, who gave this, who discovered this? Total ozone maps. It was done or achieved by Gordon Dobson. He was a physicist as well as meteorologist, isn't it? Gordon Dobson. And उसी के नाम से क्या पढ़ा है? Dobson unit. Understandable? Further take down. When the ozone concentration goes below 900 Dobson unit, goes below 100 Dobson unit, ultraviolet B rays can pass through it. Ultraviolet B rays can pass through it. Such region referred as ozone hole. Ozone hole. Fine. Understanding of ozone hole, thing which is not today. That is why this ozone hole formation have taken place in polar area, despite of the fact all ozone depleting substance were released from tropical temperate countries, developing countries. This will be explained further, but for your curiosity, you must read it from all the sources of internet. कोशिश करिएगा आप, कुछ ना होगा तो तबाह होगा। तो आगे जब क्लैरिटी आएगी तो और बेहतर तरीके से हम लोग क्लास में डिस्कस करेंगे, फिर आप दोनों को मैच कर लीजिएगा, ठीक है? हाँ, means the size in Australia, in southern hemisphere, they are shrinking. They are shrinking near Australia. Fine. Because after this Montreal Protocol, there is lot of curtailment of ozone depleting substance. We replace this ozone depleting chlorofluorocarbon by hydrofluorocarbon. And then further this hydrofluorocarbon is going to be global warming gas. Then in 97 we replaced it in Montreal Protocol. Then further we replaced this hydrofluorocarbon by hydrofluoroolefin. Right now hydrofluoroolefins are being used as a blowing agent or in air condition or wherever these ozone depleting substance are being used. So because of these curtailment, now rate of ozone depletion is getting reduced. But the thing is, they are released early, still in it is in accumulated form in polar stratospheric cloud near the pole, and it is still causing depletion. So that is the part basically dealt in environment and ecology class. So there is some limitation for geography. That's why I'm pulling back. After the class, you can have the discussion. Fine. Then, so there will be no ultraviolet rays will not pass. Simple. Barricading जो लगी है वो 100 Dobson unit की है. 100 Dobson unit से ऊपर है, so there will be no issue. UV rays will be absorbed. But if it is less than that, UV rays can penetrate, UVB rays can penetrate and come onto the earth. Then we classified these region as a ozone hole. Is it okay? So we have covered good ozone. This is doing some good job for us. Let's come to the bad ozone. Bad ozone. Basically, tropospheric ozone. Tropospheric ozone is bad ozone. Troposphere, that is lower atmospheric ozone, is bad ozone. Basically, in troposphere, this ozone is because of photochemical reaction. Photochemical reaction. Photochemical reaction is responsible for making all these bad ozone. And where this photochemical reaction taking place? Nitrogen oxides reacting with volatile organic chemical, both are released from automobile exhaust. Automobile exhaust. Nitrogen oxide and volatile organic chemical in presence of sunlight, photochemical na, so light is required. Now, photochemical reaction, and then there is formation of ozone and PAN. Peroxyacetyl nitrate. Peroxyacetyl nitrate. This is the outcome. Ozone and peroxyacetyl nitrate. Peroxyacetyl nitrate. This peroxyacetyl nitrate and ozone combination is called as what? Photochemical smog. Photochemical smog. Photochemical smog. This ozone is a secondary pollutant. PAN, secondary pollutant. What is the meaning of secondary pollutant? When primary pollutant react and they give rise to certain product which is pollutant in nature, they are termed as secondary pollutant. Like in this case, nitrogen oxide, they are primary pollutant, volatile organic chemical, they are primary pollutant. Once they react, they give rise to photochemical smog, they are secondary pollutant. Like the primary pollutant is what? Sulfur dioxide. You remember sulfur dioxide in volcano, we have discussed acid rain. It reacts with water, there is formation of sulfuric acid. That is secondary pollutant. Now you understood? So, in this case, ozone is what? Secondary pollutant. Fine. And this ozone plus PAN both constitute photochemical smog. Have you seen this photochemical smog? You are so fortunate, it is there in Delhi. अगर नहीं देखा तो अक्टूबर नवंबर में आपने जरूर देखा होगा, है ना? You'll find gray air and brown air. Every day you are going to smoke free cigarette in Delhi. Even then some foolish people buy cigarette by spending money. Because already you are blessed with such a bad air, you need not to spend money on it. Even then कुछ लोग पीते रहते हैं. नहीं पीना चाहिए, अच्छी बात नहीं. हाँ हाँ, जब नेचुरल मिल रहा है. But the thing is, it is what? Worsen air quality. Now, you will find two types of air. One is called as gray air. Gray air. When the concentration of O3 and PAN is less, and same air is going to be brown air. Brown air when there is more O3 and PAN. So have you been in Delhi in October, November? You were there? So what was your experience? Let's talk about why it is bad ozone. सर बैड ओजोन क्यों कहेंगे इसको? इसके इम्पैक्ट खराब है. तो क्या क्या इम्पैक्ट आपने महसूस किया? कुछ हो रहा था? सफोकेशन, सांस लेने में दिक्कत, और बताइए. ये सब कुछ करेगा तो इसको बैड कहोगे कि गुड कहोगे? Irritation in your means windpipe, irritation in eyes, more asthmatic attacks to asthmatic patient, है ना? वाह, सही बात है. दिल्ली का एक्सपीरियंस इन बच्चों का अच्छा नहीं रहा. कोई बात नहीं, ये संघर्ष का एक भाग है. आप अपने बच्चों को बताएंगे कि इस समय आंधी तूफान, ओले पड़ते थे, भूकंप भी आते थे, फिर भी हम पढ़ते थे, पढ़ाई नहीं छोड़ी और आज हम आईएएस बन गए. ये सारी कहानियां आप बताएंगे बात, है ना? So let's find out what are the deleterious impact of this ozone, and you will tell whether it is good or bad. So gray air, white air, this brown air, understood? Photochemical smog, because of this sunlight, in presence of sunlight, some chemical reaction involved, and that gave rise to ozone and peroxyacetyl nitrate. It's okay to everyone? Fine. Volatile organic chemical. Volatile organic केमिकल. जब आप पेट्रोल या डीजल जलाते हैं बच्चे अपने ऑटोमोबाइल में, तो ये निकलते हैं, जैसे बेंजीन, हालोइन, जाइलिन, ये सारे क्या हैं? वोलाटाइल ऑर्गेनिक केमिकल हैं, एंड दे आर हाईली कार्सिनोजेनिक. कार्सिनोजेनिक समझते हैं ना? पोटेंशियल टू कॉज कैंसर. दीज आर VOC, रिलीज फ्रॉम ऑटोमोबाइल एग्जॉस्ट. तो कहां बनेंगे ये? जहां पे ऑटोमोबाइल एग्जॉस्ट ज्यादा होंगे. तो कहां होंगे? गांव में या शहर में? शहर में या मेट्रोपॉलिटन्स में? मेट्रोपॉलिटन्स में. you'll find the graying of air and browning of air in metropolitan. And gray air, if light intensity is less, so if light intensity is less, there will be gray air. That means less formation of O3 and PAN. And when light intensity is more, so you have brown air color. So visibility is low, more O3 and PAN. Let's talk about the impacts. You can take down these impacts. You understand? Bad ozone, please take down few lines for bad ozone also. Otherwise, मुलाकात तो इसी से होनी है अगले साल भी. कहेगा मेरे बारे में नहीं लिखा है. में तो ये पहुंच सकता है ना हमारे आपके पास. Bad ozone, tropospheric ozone. Tropospheric ozone is called as bad ozone. Is called as bad ozone. Tropospheric ozone is called as bad ozone. Bad ozone. They are the secondary pollutants. They are the secondary pollutant formed due to photochemical reaction. Formed due to photochemical reaction. Photochemical reaction among nitrogen oxide and volatile organic chemical. Nitrogen oxide and volatile organic chemical. This give rise to ozone and peroxyacetyl nitrate. This give rise to ozone and peroxyacetyl nitrate. They are called as photochemical smog. They are called as photochemical smog. In low light intensity, they constitute gray air. Gray air, while in high light intensity, they constitute brown air. What is difference between gray air and brown air? Concentration of photochemical smog. Is it understandable? Are you getting my point? Fine. Ozone is very strong oxidizing agent. Oxidizing agent. Very strong oxidizing agent. As well as they are microcidal. Microcidal. Something that can kill microbes. Means ozone is microcidal and ozone is a strong oxidizing agent. So whatever you felt is your experience, but whatever the impact this ozone is going to cause has to be understood. क्या experience किया आपने कि there is itching in eyes, there is problem in breathing problem, there is increased asthmatic attacks, respiratory problems, isn't it? Visibility problem, these are the normal problem. But what else it is going to create because of these two characteristics? One is oxidizing agent as well as microcidal property. Have you ever heard about RO plus UV? RO plus ozone? Reverse osmosis plant with ozone is also there in market. And the same thing it is going to do what UV lights are doing. And that is what? Killing the microbes. Microbes get killed by the ozone. Fine. So if ozone can kill the microbes, don't you think that in the soil microflora there will be decomposers? Yes or no? And these decomposers are responsible for sustaining the vegetation over here. Sustaining the vegetation, isn't it? Because you require, as the vegetation require mineral. Who is giving this mineral to vegetation? The decomposers. What are the decomposers? They are bacteria, they may be fungi, actinomycetes, so many soil microflora will be in soil. And this ozone, it is tropospheric ozone, so it can reach to the soil or not? Yes or no? Ozone will reach to the soil and ask to the decomposer, what are you doing? They say कि we are doing decomposition in order to maintain soil microflora, sir. कि बस आज के बाद नहीं करोगे, क्यों? तुम सब मार दिए जाओगे, मार दिए जाओगे. तो क्या होगा बच्चे? The soil mineral pool get altered or not? Will it affect agricultural productivity, ecological productivity? Answer is yes. What else? This ozone is strong oxidizing agent. It can react with other chemical and oxidizes it. That means whatever the structure of that very chemical is going to be destroyed. अब आपने एक लाइब्रेरी खूब अच्छी सी बना रखी है, उस लाइब्रेरी में किताबें हैं और किताबों में लिखे हैं कुछ कविताएं, कुछ गीत कहानियां, कुछ तथ्य, कुछ इतिहास. ओजोन पहुंच गई, पढ़ने लगी, पहुंच सकती है कि नहीं? भाई ट्रोपोस्फियर में ही तो लाइब्रेरी है, स्ट्रेटोस्फियर में तो है नहीं. Now the letters which is written by the ink in the book will be destroyed, deformed. What about painting? मोनालिसा पहुंचा का तू ना हंसती है ना रोती है, तेरी नाक उड़ा दूंगा, सब तुझे देख के केवल हंसेंगे. So it can destroy the paintings. Why the paint get oxidized? सर आप जा रहे हैं अपनी शादी के लिए लड़की देखने, ले चलें इनको, आपको कोई दिक्कत तो नहीं? ठीक. और ओजोन आ चुकी है ट्रोपोस्फियर में, स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट. पहुंच गई कॉटन टेक्सटाइल फैक्ट्री में, का क्या बन रहा है? क्लॉथिंग का फाइबर. आई एम द स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट गोइंग टू डिस्ट्रॉय दिस फाइबर. दिस फाइबर इज सो वीक. यू परचेज गुड क्वालिटी क्लॉथ, बट अंदर की कहानी कुछ और थी. आप वो कपड़े पहन के चले गए, आप अपनी कार लेके गए. ओजोन ऑलरेडी रीच्ड टू द रबर फैक्ट्री बिकॉज इट इज अ स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट. उसने क्या किया? रबर के पॉलीमर को ही वीक कर दिया. नाउ द रबर इज नो मोर रबर, इट इज ब्रिटल. आप वही कार लेके गए, आप घर में बैठे, आपका कपड़ा जवाब दे गया. अब आप ओजोन को गुड कहोगे या बैड, ये आप डिसाइड कर लो, पूरी क्लास समझ जाएगी. आप जिस कार से गए वही कार पंचर हो, टायर गॉट ब्रिटल. यही नहीं, फार्मास्यूटिकल कंपनी, आपने ड्रग बनाई है बड़ी मेहनत से. द मॉलिक्यूल्स ऑफ द मेडिसिन क्रिएटेड थ्रू अ लॉन्ग रिसर्च एंड द ओजोन इन ट्रोपोस्फियर कैन रीच. हालचाल लेने क्या बना? नई ड्रग है, मुझे अच्छी नहीं लग रही, आई एम द स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट. द मॉलिक्यूल ऑफ ड्रग कैन बी चेंज. सो कैन इट अफेक्ट pharmaceutical company? What about cosmetics? Be careful. The next cream may be taken care of ozone, it will not take care of you, maybe, है ना? So ozone in troposphere, because of its oxidation, means oxidizing agent, means this ability, it can harm the cotton textile industry, polymer industry, rubber industry, paint industry, isn't it? Monuments, buildings, paintings, and above all, pharmaceutical industry. So it is going to create disaster to these industries. Shall we call it good or bad? It is up to you. Is it fine? So these are the impact of this ozone. Because of these two property, it is going to cause fertility of soil get reduced. क्या हुआ? तुम भी जाओगे तो तुम भी ना, तुम ट्रोपोस्फीयर से बाहर नहीं हो बच्चे, ये चक्कर में कि ये मेसोस्फीयर में बैठा हुआ है. क्या गड़बड़ हो गया? अभी कुछ गड़बड़ नहीं हुआ है. अच्छा, अपनी कहानी सुना दिया इतने ही समय में, इधर मत ध्यान देना, ठीक है? अपनी कहानी सुना रहा है. बताओ, ये बातें नहीं लिखी हैं आपकी किताबों में, प्लीज लिख लीजिए, प्लीज नोट इट डाउन. लिखिए, ओजोन एज अ माइक्रोसाइडल प्रॉपर्टी. नहीं, उतना ही बताएंगे कि इचिंग इन द आईज, रेस्पिरेटरी डिजीज, डिसऑर्डर, और लटके रहेंगे. यूपीएससी कहेगा ओजोन कैन इट अफेक्ट एग्रीकल्चरल प्रोडक्टिविटी, तो लटकना पड़ जाएगा. परेशान इसलिए कि क्लास में ध्यान नहीं दे रहा था, कहीं और टहल रहा था. चलिए लिखिए, प्लीज राइट. क्या लिखा? माइक्रोसाइडल प्रॉपर्टी, ओजोन बिकॉज ऑफ इट्स माइक्रोसाइडल प्रॉपर्टी kill the microbes of soil microflora. Kill the microbes of soil microflora. फ्लोरा, एज अ फ्लोरा एंड फाना ऊपर देख रहे हो ना, देयर आर माइक्रो फ्लोरा एंड फाना जो दिखते नहीं लेकिन आपके लिए काम करते हैं. दैट इज द रोल ऑफ बायोडाइवर्सिटी. इज इट ओके? सॉइल माइक्रोफ्लोरा, rate of decomposition get altered, rate of decomposition get altered, get altered. Hence soil mineral pool, hence soil mineral pool will not be replenished. Soil mineral pool will not be replenished. This will reduce soil fertility. Soil mineral pool will not be replenished. Will not be replenished. Hence soil fertility get reduced, and certainly it will affect agricultural productivity. Certainly it will affect agricultural productivity. Certainly it will affect agricultural productivity. ठीक है बच्चे? Certainly it will affect agricultural productivity. So problem of food security and other thing will be the issues. Further you can write ozone is an strong oxidizing agent. Ozone is an strong oxidizing agent. It can destroy manuscript, libraries, historical paintings, monuments and building, tropospheric ozone can give a jolt to textile industry, paint, varnish, polymer industry, rubber industry. क्यों बच्चे? क्योंकि all are having some kind of fiber and it is going to destroy, means weaken the fiber. इतना ही समझ लो. Okay, make the fiber, cotton fiber or cloth fiber weaker, isn't it? Making the rubber brittle. If rubber is brittle, it is no more be useful, isn't it? What about pharmaceutical industry? They can reach and they can destroy the purest form of medicine molecule. Cosmetic industry. So these are the industry which is going to be affected. Pharmaceutical industry, it can destroy cosmetic industry. So these are the industry which will be affected by the tropospheric ozone because they can reach into that. The premise is now it is available in the troposphere because of the photochemical reaction, and that's why it is going to cause so many impacts, bad impacts, hence they are bad ozone. Is it okay? So we have covered ozone. Yes, why not? It is human made, means indeed It is formed because of the secondary, means reaction, photochemical reaction, but the raw material is produced by automobile exhaust, burning of fossil fuel. तो कह सकते हैं हाँ. The lower stratosphere is having ozone layer, lower troposphere. It is not reaching up to stratopause. So from means just beyond the tropopause, you will start finding ozone layer, and up to 35 kilometer you find ozone layer, and then the layer of a stratopause is almost at 50 kilometer. No, means I'm not saying that there is no ozone, but the concentration, most of the concentration occur in the lower stratosphere. Most of the concentration. We can't say that there is no molecule of ozone in mesosphere. Maybe possible. There is some gases because it is composition. Up to mesosphere there is homogeneous composition. Let me explain. अब आऊंगा वहां पे. Stratopause पे temperature 0 degree हो जाता है because of the reason that there is release of heat. Heat first absorbed by ozone, then released. Let me come on to that. I will come over there. Fine. So ozone, and after ozone, next gas. You have the idea of sulfur dioxide now. Acid rain we have covered. Next important thing is particulate matter, or dust particle. First, let me explain this dust particle. And dust particle is also the part of our atmosphere. And they are doing very important job, like they cause scattering of light. They also cause reflection of light, and they are also responsible for a very important work, that is what? Hygroscopic nuclei. Hygroscopic nuclei, the dust particle. Fine. If this dust particle would not be there, you are not going to have rainfall. Means you have relative humidity close to 95, you can make the water droplets, but you are not going to make it in form of water drops. These dust particles act as hygroscopic nuclei. These dust particles do what? When there is water vapor going up, there is condensation in form of small water droplets. Small water droplets. And they are so small that they are suspended in air. They are not going to fall. They are suspended in air. Fine. They are suspended in air. They are very small. So rainfall cannot be possible. These hygroscopic nuclei do what? They give place to these small suspended water droplets. These are the hygroscopic nuclei. And what happened? These are fine, small, suspended water droplets. Suspended in air, they are not ready to fall because they are very tiny that gravity is not going to pull them down. So these are the dust particle. Dust particle. And these dust provide surface over which these fine water droplets get coalesces. They get coalesces over here. And so many small water droplets, which is earlier suspended in air, start coalescing with each other, and they form bigger water drop. They form bigger water drop. And when they form bigger water drop, this water drop is so big that it start falling under gravity. Now the gravity is taking this bigger water drop onto the earth's surface, which we call rain. That means Without these dust particles, rainfall is not possible. And this purpose, this work is called as, means this activity done by these hygroscopic nuclei. Hygroscopic nuclei. That means you can have the relative humidity in higher side. You can do the condensation. If you do not have these dust particles, you are not going to have rain. Isn't it? This is the virtue. This is the role played by the dust particle. Apart from scattering and reflection. Isn't it? And due to scattering, you know that twilight, we learned twilight earlier, scattering effect. Scattering of light is giving you the color of sky, the color of rising sun and setting sun. You all have this idea, na? It is because of scattering. Apart from it, the rainfall is due to the dust particle. They act as hygroscopic nuclei. So please take down. Dust particle plays very important role. Dust particle plays very important role in rainfall. In rainfall. After condensation, there are many fine water droplets suspended in air. There are many fine water droplets suspended in air. These water droplets are not falling down. These water droplets are not falling down. Dust particle acts as hygroscopic nuclei. Hygroscopic nuclei dust particle acts as hygroscopic nuclei where the small water droplets coalesces to form a big water drop, These bigger water drops are not stopped by air and start falling down, not stopped by air and start falling down under gravity, start falling down under gravity. We call it rain. You understand the role of hygroscopic nuclei? And artificially we provide these hygroscopic nuclei for artificial rain. We call it cloud seeding by using certain chemical. And what are the chemicals? Means we are going to discuss cloud seeding or artificial rain. In that we are using silver iodide, potassium iodide, we are using dry ice, which is called as dry ice, solid carbon dioxide, as a hygroscopic nuclei, for artificial rain. for artificial rain, isn't it? These dust particle in atmosphere, these are dust particle. But when these dust particle in troposphere and their size is enormously small, means very small, then they are pollutant also. And you might have heard about the particulate matter. Particulate matter, PM 2.5 and PM 10. So let's find it out. Particulate matter. Two types, PM 10 and PM 2.5. What is the definition of PM 10? The size of particulate matter, less than, please note it down, 10 micron. Less than 10 micron, then we call it PM 10. What about PM 2.5? When the size of particulate matter less than 2.5 micron, then it is called as PM 2.5. Both are of the category of respirable particulate matter. Both are called as respirable particulate matter. That means they get inhaled inside. And when they get inhaled inside, some of them can reach to the interstitials of our lungs. And particulate matter 2.5, they are capable of crossing that barrier also. They can reach to the blood, isn't it? So particulate matter 10, especially this one, they can cross. You can take down next point. Particulate matter PM 10 can cross respiratory barrier and reach to the interstitials of the lungs. हमारे जो लंग्स है ना बच्चे, उनका जो टर्मिनल पॉइंट होता है वो है एल्वियोलाई, जहां पे गैसियस एक्सचेंज हो रहा होता है. ठीक है. Once you take the breathe inside, oxygen goes over there and there is a gaseous exchange, oxygen taken by blood, and blood is containing carbon dioxide. This carbon dioxide comes over there and you exhale the air, isn't it? Every time you are doing this. So the alveoli is the site of gaseous exchange, and these particulate matter go there and start depositing on the wall of alveoli. I'm just giving you the idea. This is your trachea, then this is your respiratory system, and both the trachea means the trachea divided into bronchi, and this bronchi connected with the lungs. The bronchi further divided into bronchioles, and all the bronchioles are further divided into various numerous respiratory bronchioles. And the terminal position of these respiratory bronchioles are having those alveoli. And these alveoli are the site of gaseous exchange. I'm just going to magnify this alveoli. So this is your trachea, the windpipe, then two bronchioles, both terminating into the lungs, spongy lungs, and inside story is what? This bronchiole, this bronchi terminated into various bronchioles, and bronchioles into numerous respiratory bronchioles. And all respiratory bronchioles terminate into alveoli. I'm just giving you the idea. This is your alveoli. Fine. Very thin walled, single cell thin, isn't it? And this is the windpipe, means the respiratory bronchiole. And around this alveoli, you are going to have richly supplied blood vessels. These are the blood vessels. Why I'm putting all these biology part here? Because last year they have asked the respiratory barrier and blood barrier. So they may put such kind of question. They have the understanding, means they are asking the question from such area which is not at all related with geography, but you need to know. Fine. These are the blood vessels. And the blood vessels containing blood, containing hemoglobin. So what happens once you breathe inside, you have air. Air is containing 21% oxygen, isn't it? And air is also containing 0.03% carbon dioxide. Nitrogen का कोई लेना देना नहीं है. And this blood is containing more carbon dioxide. So here carbon dioxide concentration will be more and oxygen concentration is less. And there is hemoglobin. So what happened? Similar, means you can understand easily that oxygen come inside, carbon dioxide taken back. So this alveoli surface is going to be the surface of gaseous exchange. Are you getting my point? Okay. And there is an exchange of oxygen and carbon dioxide. Then what you do? You take out this gas outside. Now particulate matter 10 will do what? They can cross this entire barrier. Up to here, it is called as respiratory barrier. And they start depositing on these surface. These are the area where the particulate matter 10 start depositing. So will it reduce the surface area for gaseous exchange or not? These are the place where your particulate matter means 10 is going to deposit. And similarly, it happens after smoking too. The carbon tar is going to deposit in the interstitial. It will reduce the surface area. Reduction in surface area of gaseous exchange will reduce the oxygen supply to your body. Yes or no? When oxygen supply is reduced, your immunity, your metabolic activity, everything is going down. और ऐसी स्थिति में एक बैक्टीरिया अभी अभी आपके अंदर गया है, वो निकल भी आया, नाम है माइकोबैक्टीरियम ट्यूबरकुलाई, जो टीबी कॉज करता है. किसको? जिसकी इम्यूनिटी जियोपार्डाइज्ड है, उसको टीबी हो जाता है. So you'll see whenever the immunity gets jeopardized, the person is going to suffer from tuberculosis, isn't it? So this PM, this is what? PM10, particulate matter 10. They can cross the respiratory barrier and reach to the terminal position of your lungs. And what about PM2.5? They are so dangerous that they directly cross the blood barrier. They reach directly to the blood vessels. They are not stopped even by the alveoli, and they reach to the blood vessels. And if suppose that this particulate matter 2.5 is carcinogenic, so now cancer is not going to confine at one place. It is part of blood, so it can circulate it everywhere and anywhere in the body. So these particulate matter 2.5 is going to be hazard for us. There are number of cases which is on increase, and in future you will find so many articles written on particulate matter, especially 2.5. They are aspirable particulate matter. They are suspended in air for longer duration. Once you inhale, they go inside the interstitial. 10 get means deposited on the interstitials, but 2.5 can cross even that and reach to the bloodstream directly. So they are creating more deleterious impact. This is what the story of particulate matter you should know. You want to write? Please take down. Particulate matter 10. Particulate matter 10. Particulate matter 10, PM10. They are smaller than the 10 micron, respirable, suspended respirable particulate matter, suspended respirable particulate matter. They reach up to 10 micron, less than 10 micron. You know micron, angstrom? चुप हो जाऊं कि चलता रहे? ओहो, ये तो चल रहा है। अरे अरे, ज्यादा देर से? अच्छा। Suspended respirable material inhaled and reach up to alveoli of the lungs, get deposited there and reduce the surface area of gaseous exchange. Reduce the surface area of gaseous exchange. Is it okay? In bracket you can write, they can cross the respiratory barrier. Okay. PM 2.5. PM 2.5. Particulate matter 2.5. They are smaller than the 2.5 micron. They are smaller than the 2.5 micron. And they can cross the blood barrier. Is it okay? Particulate matter diagram. Fine. This one, here it is alveoli, and these are the blood vessels. You will find the impure blood, that is deoxygenated blood, and once it is getting oxygen, it becomes oxygenated and further sent to the lung, heart will send to the entire body. Is it okay? You understood this? So particulate matter, one more gas is there, that is what? Methane. Let's cover it. Shall we? चलो आगे. आज रहने देते हैं, बहुत पीछे. CH4, methane. It is also called as marsh gas. Why it is called as marsh gas? Because दलदली भाग से ये हमेशा निकलते रहते हैं. तो क्यों निकलते हैं? क्योंकि क्या होता है बच्चे दलदल में, आइए समझते हैं. This is the ground and it is in waterlogging condition. There is waterlogging condition in the marsh. So what happened to the ground? The ground is having some organic material over here. Fine. But this is the ground, this is the soil, and here it is organic material. And in the marshland, in the bog, in the fen or wetland, you happen to have this waterlogging condition. Wherever you will find waterlogging condition, you will find this kind of reaction going on. Whether it is bog, fen, marsh, or it is rice paddy field. वहाँ भी ये स्थिति होती है because rice require lot of irrigation. So most of the time you will find that it is waterlogged. So when there is waterlogging condition, there will be an interface created between soil and atmosphere, and that is of water. Earlier, what happened when this water was not there, the soil was in direct contact with the atmosphere, and this soil was having oxygen. And when this soil was having oxygen, the decomposers are both aerobic and anaerobic. But what happened now, the oxygen is not able to reach over here. So which decomposition is going to be prominent? The anaerobes. And anaerobe bacteria largely constituted by methanogenic bacteria. You'll find methanogen over here. Methanogens. They are the archaebacteria. They turn organic material into simple organic material, and in the process methane gas evolve. तो यहां से क्या निकल रही है? Continuously methane gas. Why? Because there is anaerobic decomposition. ठीक है बच्चे? And wherever this condition prevail, you will find methane is going to evolve. हर दलदल से मीथेन निकलेगी. क्यों? क्योंकि there is water logging condition, and this water logging, this interface of water reduce the diffusion of oxygen. ऑक्सीजन नहीं रहेगा तो ऑक्सीजन डिपेंडेंट जो माइक्रोब्स हैं वो रहेंगे क्या? आप बताइए, नहीं रहेंगे. तो कौन यहाँ पे डिकम्पोजिशन कर पाएगा? एनारोब्स. एंड लार्जली दे आर मेथेनोजन, एंड मेथेनोजेनिक बैक्टीरिया विल रिलीज मेथेन. That's why marsh, bog, fen or any waterlogging condition is giving you methane, and methane is potential global warming gas. Rice paddy field से भी निकल रही है methane, and this is the reason why developed countries are pointing finger upon India, China, Brazil that don't go for cultivation of rice. तो हम क्या कहते हैं? तो ग्लोबल वार्मिंग से तो बाद में मरेंगे, भूख से पहले मर जाएंगे, तो तुम भाड़ में जाओ, हम चावल उगाएंगे. दिस इज आवर स्टैंड. मतलब हाँ, ऑफिशियली उसको अच्छे से कहा जाता है, बट द थिंग इज सेम. राइस पैडी फील्ड मीन्स राइस कल्टीवेशन इज एसोसिएटेड विथ मेथेन, एंड मेथेन इज अ पोटेंशियल ग्लोबल वार्मिंग गैस. Almost 23 times more potential, means more than the carbon dioxide to cause global warming. Isn't it? But the thing is, if we reduce cultivation of rice, if we stop cultivation of rice, 50% Janta depends over it. It is the staple crop of India. Not only India, the developing country. So how come we will feed our population? और ऐसा नहीं है कि हम लोग छोटे मोटे परिवार वाले हैं. सबसे बड़ा परिवार है. तुम्हारे ग्लोबल वार्मिंग से मरेंगे कि नहीं, लेकिन बिना खाए तो दिक्कत होगी ना. That's why we refused all such initiatives in which we have to stop our rice cultivation. चाहे वो मेथेन प्लेज हो, चाहे फिर ग्रीन कॉरिडोर हो, ग्रीन शिप कॉरिडोर, ये सारे इनिशिएटिव्स आपको कॉन्फ्रेंस ऑफ पार्टीज में दिखाई पड़ते हैं. इंडिया इज नॉट द पार्ट ऑफ दैट. व्हाई? बिकॉज द प्राइमरी ऑब्जेक्टिव ऑफ इंडिया इज टू फीड आवर population, and our staple crop is rice. Yes, we will stand with you by all other means, ways and means, like we are going to use solar energy, we are having the solar alliance, we are going to use wind energy, we are doing other activities like disaster resilient infrastructure. Such initiatives India is taking forward. But yes, we can't jeopardize our agricultural productivity because it is the need of the hour. Is it okay? So methane, लिख लीजिए, methane also called as marsh gas, auto gas, sweet gas, these are the name. And the main component of natural gas. बच्चे नेचुरल गैस इज फ्यूल, natural gas, or 87% to 92% of natural gas belongs to methane, isn't it? Main component of natural gas. Methane produced due to anaerobic decomposition. Methane produced due to anaerobic decomposition. अच्छा, क्यों anaerobic? Because of water logging. Very simple. If there is an interface of water in between soil and air, so how comes oxygen is going to penetrate that water interface? Isn't it? So there will be anaerobic decomposition. Methanogens are the champion anaerobes widely present in soil. Widely present in soil. Widely present in soil. तो कहां से मेथेन निकलेगी? राइस पैडी फील्ड, ध्यान रखिएगा, एक छोटी सी लाइन लिख लीजिए, मेथेन इज पोटेंशियल ग्लोबल वार्मिंग गैस. मेथेन इज पोटेंशियल ग्लोबल वार्मिंग गैस. पोटेंशियल ग्लोबल वार्मिंग गैस. और इसका अगर ग्रीन हाउस पोटेंशियल देखना चाहोगे तो इट इज 23 टाइम्स मोर देन द कार्बन डाइऑक्साइड. इजंट इट? कार्बन डाइऑक्साइड को पैमाना माना गया है, और बाकी के गैसेस जो 6 ग्रीन हाउस गैसेस हैं जिसको आप लोगों ने पढ़ा होगा या पढ़ेंगे, वो क्या है, उसके आधार पे आप देखते हो ग्लोबल वार्मिंग पोटेंशियल ऑफ द गैसेस. इजंट इट? Methane is 23 times more than the carbon dioxide. So this is the end of the composition of gases. Yes, क्या कह रहे हैं? नेचुरल गैस यार, साइंस टेक में आपको एनर्जी पढ़ाई जाएगी जिसमें नेचुरल गैस में कितना कंपोजिशन होता है मेथेन का. सो नेचुरल गैस कंसिस्ट ऑफ मेथेन, एथेन, प्रोपेन, ब्यूटेन. आउट ऑफ दीज 4 गैसेस मेथेन इज 87 to 92%. नेचुरल गैस सुना है ना, एलएनजी, पीएनजी, कंप्रेस्ड नेचुरल गैस, पाइपलाइन नेचुरल गैस, पीएनजी, सुना है ना? So that contains methane, ethane, propane and butane, 4 gases. Out of these 4 gases, methane has maximum contribution of 87 to 92%. This I mean to say. Next topic is zonation in atmosphere. Zonation in atmosphere. So our atmosphere, we divide this atmosphere on the basis of their characteristics into following zone, and the zones are, this is the surface of earth, and just above the surface of this earth, means on an average 13 kilometer above the surface of the earth, we have troposphere. Troposphere. At equator, this troposphere, maximum height of troposphere is of 18 kilometer, while at pole it is just 8 kilometer. And the limit line between troposphere and stratosphere is called as tropopause. Tropopause. Above tropopause, up to 50 kilometer, we have stratosphere. Stratosphere. And above stratosphere, again, we happen to have stratopause. Stratopause, tropopause, these all are the transition zone that culminates the particular sphere, isn't it? So you will find stratopause over here. Stratopause. Then next layer up to 80 kilometer 50 to 80 kilometer. That means for 30 kilometer, and from the Earth's surface up to 80 kilometer, between 50 kilometer, this is what called as mesosphere. 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 Fine. Up to 80 kilometer, you happen to have mesosphere. And above 80 kilometer to 480 kilometer, this is the zone, we call it thermosphere. Thermosphere. Also referred as ionosphere. Ionosphere. Up to 480 kilometer. Okay. And beyond this, up to 29,000 kilometer, we referred it exosphere. This is the zonation of atmosphere on the basis of change in temperature and various characteristics. There are various characteristics you will find in each sphere, and they are peculiar to these area, these zone, isn't it? Not only this, up to 80 kilometer, from Earth's surface to 80 kilometer, this is the atmosphere which is having homogeneous composition of gas. That's why it is also referred as homosphere. You will find almost homogeneous composition of gas. Gaseous concentration is going to be same. The density may vary, but the composition is going to be same. And beyond 80 kilometer, that means the part of thermosphere, exosphere, this all represent heterogeneous composition of gas. That's why it is called as heterosphere. So in homosphere, we have three, that is what? Troposphere, stratosphere, and mesosphere. While in heterosphere we have thermosphere and exosphere. What is the difference? In homosphere you will find similar composition of gas. That means nitrogen, oxygen, argon, carbon dioxide, water vapor and all. This is in what? Same composition, except water vapor. We can't say water vapor, very less water vapor in mesosphere and all that. But yes, some amount will be there. But in case of heterosphere, you have change composition, different composition. Largely there will be nitrogen and oxygen only. Rest of the gases are not present. Fine. So you will find heterospheric composition in heterosphere that represent your thermosphere or ionosphere and exosphere. While troposphere, stratosphere and mesosphere are having homogeneous composition. Is it okay? And each sphere has its peculiar characteristic which we are going to discuss. The first sphere is troposphere. Shall we go for it? उतार लिया है किलोमीटर. अच्छा यहां बताओ स्पेस कहां शुरू हो जाता है? एक्सोस्फीयर. हाँ, आइनोस्फीयर. अच्छा लो उसके नीचे. हाँ अच्छा सुन लो. अर्थ सरफेस से 100 किलोमीटर की ऊंचाई पे एक लाइन है बच्चे, नाम है इसकी कार्मन लाइन. कार्मन लाइन कहां पे है बच्चे? 100 किलोमीटर फ्रॉम द अर्थ सरफेस. इसके बियॉन्ड क्या है बच्चे? स्पेस. उससे पहले आप कहां हो? उसको हम एटमॉस्फेयर मानते हैं. ऑल्दो एटमॉस्फेयर एक्सटेंडेड अप टू 29,000 kilometers, but this Kármán line is a boundary that defined beyond which space starts. isn't it? Shall we proceed? First one is troposphere. Let's talk about troposphere. 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 If you see the root word tropos, that means first one is turbulence. Turbulence or mixing. So where the mixing is going on, where the turbulence is going on, is what called as troposphere. This is the sphere, lowest sphere of our atmosphere, where all weather phenomena taking place. Weather phenomena taking place, not all. It's almost all weather phenomena taking place. That's why it is also referred as weather sphere. Also referred as weather sphere. लिख लीजिए. Troposphere is the lower atmosphere. Troposphere is the lower atmosphere. Average height is of 13 kilometer. Average height is of 13 kilometer. Weather phenomena like atmospheric circulation, condensation, rainfall, atmospheric circulation, condensation, rainfall, various types of cyclone, etc. taking place in this sphere. Hence it is called as weather sphere. इसको क्या कहते हैं बच्चे? वेदर स्फीयर. ठीक है. The boundary of troposphere is referred as tropopause. The boundary of troposphere referred as tropopause, that acts as lid. ढक्कन की तरह काम करता है. Lid over troposphere. That acts as lid over troposphere. Height of tropopause varies. Height of tropopause varies both spatially and temporally. Height of tropopause varies spatial variation and temporal variation. Spatial variation का मतलब बच्चे along the latitude. So at 0 it is 18 kilometer. At pole it is just 8 kilometer. ठीक है. And what about temporal variation? Seasonal variation. In winter, height of tropopause is different. In summer, height of tropopause is different. Why and how this variation is taking place? Let's find it out. Shall we? So as I told you, that height of tropopause is 18 kilometer near equator. How much? 18 kilometer. And height of tropopause is just 8 kilometer at pole. This is suppose that North Pole. Fine. At equator, the height of tropopause is 18 kilometer. At pole, the height of tropopause is just 8 kilometer. Why the height is low here? कौन बताएगा? नहीं, हमने यहां पूछा लो क्यों है? कन्वेक्शन करंट. हाँ. So what happened? There is convectional current or there is something else? No, there is no convectional current. There is sinking of air taking place. What happened? हाँ, क्या कह रहे हो? रेडियस छोटा है. अब थोड़ा सा फ्लैट है तो ग्रेविटी का भी फर्क पड़ेगा. Listen me. Here, at pole you have low temperature, and due to low temperature, what happens? There will be thermal. क्या होगा बच्चे? Contraction या expansion? Contraction. And when there will be thermal contraction, what happens? The air density will increase or decrease? Air density. Thermal contraction. The volume get reduced. Mass is same. Density will increase. Air become heavier. And heavier air tend to sink. So you will find sinking air over there. So यहाँ पे air try to sink over here. That's why you will find that height of tropopause is low. And further it is lowered by the high gravitational force. At pole, you are going to have high gravity. So because of the gravity, but primarily because of low temperature, pole is going to have just 8 kilometer height of tropopause. Is it okay? क्या हुआ? That is what? The low temperature. No, it is prominent. The low temperature is because of lower absorption, because of lower insolation. There is always oblique rays that is falling on equator. So equator receive less insolation. Hence there is low temperature. And low temperature will do what? Thermal contraction. And due to thermal contraction, air contract and density increase. Hence air become heavier. Heavier air tend to sink. That's why the height of tropopause is just 8 kilometer at pole. Further, at pole you happen to have high gravity. So gravitational force is little bit high as compared to the equator. That's why the air is also get pulled downward, isn't it? So please take down. The height of tropopause is just 8 kilometer above equator. Height of tropopause is just 8 kilometer above equator. It is due to height of tropopause just 8 kilometer above pole. It is due to low temperature that result thermal contraction. Low temperature that results thermal contraction. Air become denser and heavier, hence tend to sink. Sinking air makes the height just 8 kilometer. Makes the height just 8 kilometer. Further, at pole there is high gravity that also pull the atmosphere bit closer. It also pull atmosphere bit closer. What is happening near equator? There is rise of convectional current. in the morning session, means we have discussed the rise of convectional current. There will be rise of convectional current. What happened? Air will rise along. Why air will rise? Because of high temperature. And high temperature, there will be low pressure. Why low pressure? Where thermal expansion. And thermal expanded air will be lighter. And lighter air tend to rise up. So rising air create low pressure, isn't it? तो सराउंडिंग से वहां एयर आती है और भी ऊपर उठने लगती है, isn't it? So you will find high temperature associated with low pressure, and there will be thermal expansion. Thermal expansion. Air become lighter. Yes or no? Air become lighter, and lighter air tend to rise. So there will be rise of air. And do remember, this area is also having lots of water. Water is here. And because of high temperature, there will be evaporation that is also taking place. So rising air along with water vapor. And water vapor has latent heat that acts as heat engine. So what happened? This rising air goes up here. There is condensation and cloud formation, and each condensation is going to release latent heat of vaporization, further rise, further condensation, further latent heat of vaporization, further rise, further condensation. So due to this kind of multiple condensation and release of heat, latent heat every time, there will be further rise taking place. This is the reason you will find the height of tropopause is of 18 km. And this process is called as rise of convectional current. Here convection is going on. Convectional current. So in one word, the rise of convectional current. Rise of convectional current. Rise of convectional current is taking place over here, and that's why up to 4 PM सुबह से लेके 4 बजे तक क्या होता है? केवल और केवल क्लाउड फॉर्मेशन, वर्टिकल एक्सटेंट ऑफ क्लाउड फॉर्मेशन in equatorial region, and after 4 PM there is rainfall. 4 PM rain, convectional rainfall. This is the virtue of equatorial region. So when we talk about the climatic region of the world, we will go for tropical equatorial rainforest. So every day you will find rainfall taking place, convectional rain. So why the height is more? Because of multiple condensation and release of latent heat, there is further rise taking place, and that's why the height of tropopause is 18 km. Further, when we go up in troposphere, there is a decrease in temperature. As we move up in troposphere, there is decrease in temperature, and this decrease is by 6.5 degrees centigrade per kilometer. So this is average decrease. That means after each 1 kilometer, it is not necessary that there is a decrease of 6.5 degrees centigrade. It may vary, but on an average, this decrease is 6.5 degrees centigrade per kilometer. This decrease in temperature is called as normal lapse rate. Normal lapse rate. After each kilometer, there is a decrease in temperature by 6.5 degrees centigrade. Some book refers 6.4 degrees centigrade. It's okay. My question is, why there is a decrease in temperature while going up into troposphere? क्या निकलता है? Why there is insolation? धरती से निकलता है मूर्ख. अच्छा, क्यों? Why there is decrease in temperature while moving up in tropopause? What is the reason behind it? तो क्लाउड तो है आपका 6000 मीटर ऊपर, अभी बात मैं कर रहा हूं 1 किलोमीटर ऊपर की, वहां भी डिक्रीज हुआ, 2 किलोमीटर वहां भी डिक्रीज हुआ, अब क्लाउड आएगा आपका लोअर क्लाउड। तो सर आप बताइए, क्लाउड से घेर रहे थे तब तो सही नहीं है, और लोग बताएं, समझाएं। वाई देयर इज डिक्रीज इन टेम्परेचर वाइल मूविंग अप इन ट्रोपोस्फियर। समय भी हो गया है, तो इसी सवाल पे आपको छोड़ के जा रहे हैं। हाँ बताएं। हाई टेम्परेचर, हाई टेम्परेचर की वजह से मतलब हाँ, लेटेंट हीट कुछ एक्सप्लेन करिए, क्यों लेटेंट हीट बता देने से नहीं, आप बताएं सर। नहीं, क्लाउड फॉर्मेशन तो होगा, इट विल टेक प्लेस आफ्टर 1.8 किलोमीटर, बिफोर दैट there is decrease in temperature. If you are moving up, means after half kilometer, there is decrease in 3.5 degree centigrade temperature. Why this decrease is taking place? Very good. He explained it well. You understood? The concentration of greenhouse gases as we move up is getting reduced. And this concentration of greenhouse gas is responsible for heating effect. Their absorption, starting from the Earth's surface, they are absorbing long wave terrestrial radiation. And you all have this idea that up to 5 kilometer, you happen to have 90% of water vapor. Water vapor is a main greenhouse gas along with carbon dioxide. So what happened? As you move up, the greenhouse gas concentration get reduced. So their absorption get reduced. So their counter radiation get reduced in the same amount. This is the reason why we go up, we see that there is a decrease in temperature by 6.5 degrees centigrade per kilometer. And do remember, it is not absolute decrease. It is average decrease. Isn't it? So you understood? अच्छा, एक सवाल और बता दो चलते चलते. What will happen to the height of tropopause in summer and winter? समर में बढ़ जाएगी. क्यों बढ़ेगी? थर्मल एक्सपेंशन. और विंटर में घटेगी, थर्मल कॉन्ट्रैक्शन. सिंपल फॉर्मूला, हाई टेम्परेचर थर्मल एक्सपेंशन, लो टेम्परेचर थर्मल कॉन्ट्रैक्शन. एक्सपेंशन लाइटर एयर, कॉन्ट्रैक्शन हेवियर एयर. ठीक है बच्चे, तो एक बार पढ़ के आइएगा, कल इसके आगे की कहानी. थैंक यू वेरी मच फॉर टुडे.